Hello everyone. So let us see the eddy current dynamometer with respect to sensors and transducers. So what is this eddy current dynamometer? Why it is used? What is going to measure? Let us see the construction and also the working, how it works. So those things we'll discuss in detail. So here, this is the eddy current dynamometer. So basically, this eddy current dynamometer is used to measure the shaft power. So whatever the rotating mechanism will be seen in any of the industries or in automobile or anywhere. So whenever any shaft of that rotating devices are there, so we'll be able to measure what is the power at the shaft. It can be measured using this kind of a device that is called a eddy current dynamometer. The name itself says it's nothing but a eddy current. So basically the eddy current is nothing but the current which is produced due to the leakage of flux which is happening, and that leakage of flux is linked to the nearby any of the nearby devices or conducting elements. You can say that in the form of heat, that is called a eddy current, right? The same concept has been utilized in this eddy current dynamometer. So where we make use of this eddy current to measure the shaft power, right? So let us see the construction part first. So this is a diagram for an eddy current dynamometer, which consists of stator as well as a rotor here. So where you can see that this is a stator part. The stator consists of a cast iron, so in the section which is given here, and the rotor which is a consists of a steel teeth. So where you can see that it's like a tooth shape. It is not actually a full core or cylindrical or non-cylindrical type, so which has a toothed steel rotor, which you can see the shape of the rotor here. This is the shape of the rotor, where rotor is mounted on the shaft of your motor, and this is the stator part which is present here, and it has something like a cooling ducts here, which you can see will be explained in detail. And same way the cooling duct, it has a this is an inlet cooling duct and this is outlet cooling duct, you can say. So on the stator, it consists of a exciting coil. So where it consists of a coil here, so where the coil will be excited with respect to the power supply, which is not shown in the diagram. So usually it will be excited with the power supply. So where you can see the either side of the stator part, it consists of a coil, similar like your normal motor. If you take where the stator consists of a poles, and on the pole the windings will be wound over there, the same way it consists of a coil over here, right? So this is with respect to the construction part. So now let us see the working part, how actually the device will work to measure my shaft power here. So here whatever the device you want to measure the shaft power of the particular device, which will be coupled to this eddy current dynamometer, so which will be coupled to that. So as per the rotating part of any machine will be rotating, so based on that, because of the coupling, so this device also will start rotating here, right? The rotor will be rotating here. And the stator part, as I mentioned here, it consists of a coil here, excitation coil, where the coil will be excited by using a source. So when the supply is given to this, the coil will be excited. When the coil is excited, it produces a EMF. So which you can see the flux lines which is been shown. The flux will be induced in that coil. So now this induced coil will be having which will be flowing outside. So where you can see it was supposed to be flow circular to this coil. So whenever the rotor rotates here, if you observe here, whenever the rotor rotates, so the rotor part, actually it's a short circuit type of rotor, where because of the short circuit the EMF is flowing here, and the direction of the flux is also given here. So whenever the rotor rotates, these flux lines will get cut. So because of that, the EMF will be induced in this in the form of a heat, because it's a eddy current type, the form of the heat. To remove that heat, they make use of a inlet cooling, water cooling. So they make use of a water here, the inlet cooling. So this water will remove the part of a heat which is obtained due to the eddy current in the dynamometer, and some other part of a heat is removed within this air gap. You can see the air gap between the stator and rotor here, the gap which is shown here. At that it has a air gap, because of the air circulation also the heat will be, some part of the heat will be removed. So that the water is inlet here and the water is given, the outlet of the water cooling is given here, the water comes out. So as and then the rotor rotates, the EMF will be induced in the rotor, so that EMF will be measured. The EMF will proportional to the your shaft power, where it has simple formulas are given. So based on that formula they try to determine the shaft power here. So this is regarding the measurement of shaft power using the eddy current dynamometer. Coming to the advantages part, good control at low rotating speed. Because of the speed which has very low rotating speed, the control is very good. We can control the speed here. Comparatively small size for a given capacity. So the size of this device is very small, which can be coupled easily to any of the rotating machine where you're supposed to measure the shaft of the power. And it is also suitable for higher speed range also. It is also possible. Even the speed is more than 1500 or 2000, above that also it is possible to adopt this mechanism, where it is easy to identify the power using the eddy current dynamometer. So this is regarding the measurement of eddy current dynamometer, which is used to measure the shaft power. So this is regarding this. Thank you.